Welcome to the part 2 of this module 4. In the part 1 we have seen what is physical geology and we have seen what are the soils and landforms that are formed by natural agent river. So there are three well defined phases in the geological work of river: erosion, transportation and deposition. Erosion. Due to erosion, the structures that are formed are potholes, river valleys, gorges and canyons, waterfalls. The transportation. The river carries the sediments as either by suspended load, bed load or dissolved load, and also due to deposition of sediments by river water creates natural structures like alluvial fans and cones, natural leaves and deltas. Now we will be seeing geological work of groundwater. Groundwater, like surface water, is also a very powerful natural agent responsible not only for modifying the existing features but also for creating many other geological features on and below the surface of the earth. Geological works of groundwater may be conveniently studied under two headings, namely chemical work and mechanical work. Geological work of groundwater. Chemical work. Water is a great solvent. Groundwater becomes an active agent of dissolution of many rocks like limestone, dolomites, gypsum, rock salt and the like with which it comes into contact during its downward journey below the surface. It has been observed that water dissolves limestone at a variable rate that depends upon its temperature, composition and above all its carbon dioxide content. So here basically what they are saying is the underground water reacts with various minerals in the rocks that are soluble in water and it dissolves those rocks to create new structures, new natural forms. The first type of natural structure that is formed due to groundwater is dolines. These are also termed as swallow holes, sink holes, and sometimes simply called as sinks. A typical doline is circular or oval depression, which when followed in depth becomes bowl-shaped or cylindrical in cross-section. So these dolines, when we look at the surface, it looks like a circular or oval depression, but when we go inside the Earth's surface, it becomes bowl-shaped or cylindrical in cross-section. This happens in the rocks where it contains minerals that are soluble by water. There are different types of dolines which are shown in the figure: solution doline, collapsed doline, dropout doline, buried doline, caprock doline, and suffusion doline. Caves. These may be defined as naturally carved out underground cavities of various dimensions that always have horizontal opening on the surface. They are similar to tunnels with the exception that a cave does not normally have an exit on the other end. So these are not man-made caves, these are caves made by geological work of groundwater. The difference between cave and a tunnel is tunnel you can go through one side and come out from the other side, whereas in cave there is only one entry and there is no exit point, or there is only one point which can be used for either entry and exit. Blind valleys. This is similar to what we have seen by geological work of river water valleys. In geological work of river water, the valleys will be formed on the surface of the earth, whereas here in groundwater it is formed below the surface of the earth. A blind valley is a valley-like feature where a stream flowing through it in the upper reaches suddenly disappears in the lower reaches. Geological work of groundwater deposition. Groundwater is also an active agent of deposition in regions of proper climate and geology. These deposits are typically found to occur in caves and other underground openings, and also fissures and cracks in the form of mineral bands. mineral streak, or even as distinct mineral layer. Among the minerals very often deposited from the groundwater by precipitation etc. may be mentioned varieties of calcite, silica, fluorite and barite. The sediments that are carried in the river water will be deposited in the pores, fissures, cracks in the form of mineral bands in the rocks. The two most commonly known cave deposits are stalactites and stalagmites. Stalactites are carbonate projections that hang down from the roof of the caves. They may occur fantastic shapes like slender rods and cones with flattened bases attached firmly with the roof. Stalagmites are also groundwater deposits of carbonate-rich droplets from ground upwards. So stalactite, it will be vertically downward attached to the roof. Stalagmite, it is vertically upward. These are shown in the figure. The first figure is an example for stalactites and the second figure is example for stalagmites, and the third, both are shown in the pictorial way, stalactite and stalagmite. So geological work of groundwater. In chemical work we have seen through erosion the natural forms that are formed by geological work of groundwater are dolines, caves and blind valleys, whereas the natural forms that are made by deposition of geological work of groundwater are stalactites and stalagmites. Mechanical work. Geological work of groundwater, mechanical work. Subsurface water is also invariably characterized with some motion due to one or another reason, for instances, under the influence of gravity in the zone of aeration and that of hydrostatic head in the aquifer and underground streams. The velocity of subsurface flow, however, is much less when compared to surface water. Hence, the mechanical work of subsurface water is more in theory than in practice. The groundwater also moves due to various reasons. It moves either under the influence of gravity or due to hydrostatic head, difference in hydrostatic head. But even though it moves, the velocities are very much lesser. Hence, the mechanical work of subsurface water is almost negligible. Geological work of wind. Air in motion is called wind. Wind is one of the three major agents of change on the surface of the earth, the other two being river and glaciers. Similar to river water, this geological work of wind has also three well-defined phases: erosion, transportation and deposition. Wind acts as an agent of erosion, as a carrier for transporting particles and grains so eroded from one place, and also for deposition huge quantities of such wind-blown material at different places. So, the natural forms that are made due to erosion of wind. The first natural form is deflation. Deflation is nothing but accumulation of coarser particles, larger pebbles. So, as you can see in the figure, when the wind flows, it carries the finer particles along with it. The heavier particle gets settled downwards. As the process accumulates, upon a particular point of time, there are no finer particles available in the pavement. There are only coarser particles which cannot be transmitted by wind available, and it forms a natural form called deflation. Wind abrasion. It is very similar to river abrasion. Wind carries finer particles when it flows, and these finer particles collide with the stones, causing the stone to get abraded. Attrition by wind. The sand particles and other particles lifted by the wind from different places are carried away to considerable distance. The wear and tear of load particles suffered by them due to mutual impacts during the transportation process is termed as attrition. So attrition is a wear and tear of the sedimented particles, wear and tear of the transported particles by the wind. Sources of sediments. Wind is an active agent of sediment transport in nature. Materials of fine particle size such as clay, silt and sand occurring on the surface of earth are transported in huge volumes from one place to another in different regions of the world. Since the wind can carry only finer particles, most of the landforms associated with the deposition of wind are made up of clay, silt and sand, which will occur on the surface of the earth. How the wind transports? The wind transports the particles by two methods, suspension and siltation. Suspension. The light density clay and silt particles may be lifted by the wind from the ground and are carried higher up to the upper layer of the wind, where they move along with the wind. This is called transport in suspension. The particles are suspended in the wind. Whereas the second mode of transport, siltation, the heavier and coarse sediments such as sand, grain, pebbles and gravels are lifted up periodically when during high velocity wind only for short distance. They may be dropped and picked up again and again during the transport. So process siltation is therefore process of sediment transport in a series of jumps. In the next slide is shown. There are two. When wind blows, the finer particles are carried inside the wind and moves away. It is in a suspension way, whereas the heavier particles, when the velocity of wind is higher, it goes up and falls down, and again the wind velocity picks up, the heavier particles again transported and falls down. This series of jumps of transportation method is called saltation. Geological work of wind deposition. The natural forms that are formed due to deposition of materials by wind is called alien deposits. There are mainly two types of deposits. One is dunes and another one is loess. We will see first what is dunes. These are variously shaped deposits of sand-grade particles accumulated by wind. A typical sand dune is defined as broad conical heap. A dune is normally developed when a sand-laden wind comes across some obstruction. The obstruction causes some check in the velocity of the wind, which is compelled to drop some load over, against, or along the obstruction. When the process is continuing for a long time, the accumulated sand takes the shape of a mound or a ridge. This accumulated sand, it is called dune. These are some of the figures showing alien deposits, dunes, loess. The term loess is used for wind-blown deposits of silt and clay-grade particles. Typically, loess is unconsolidated, unstratified and porous accumulation of particles. Strong winds blowing over very extensive area of deserts, outwashed plains and soils loosened by plough pick up vast amount of fine-grade particles for transportation in suspension. When such dust-laden winds passing over steeps and other flat surfaces are intercepted by precipitation, they drop their entire loads on the surface below. This process is repeated for years, and accumulation of such sediments over years have resulted in the present loess deposits. These are examples of loess deposits. Geological work of sea. Since the water in the ocean is stagnant, the natural forms, the geological work of sea is mainly due to waves and currents. The process of erosion happens in the oceans in the form of marine erosion, marine abrasion and marine corrosion. Due to erosion, the natural forms that are formed are headlands and bays, sea cliffs, wave-cut terraces and beaches. Geological work of sea deposition. Coral reefs. These are peculiar type of ridge-like marine deposits that have been found due to accumulation of dead parts of certain types of sea organisms. Corals are typically a calcium-secreting organisms, predominant the source of such reefs, hence they are commonly designated as coral reefs. Thank you.